Well, hello again, everyone. This is Mr. Reeves back with you as we continue working our way through the Grade 7 CAASPP Math Practice Test. We have finished the first 10 problems, and now we're going to be doing the next 5, starting with number 11. All right, question number 11 says a bag contains 16 marbles. There are 5 blue, 9 yellow, and 2 red. One marble is selected at random. Determine whether each statement correctly describes the likelihood of an event based on the given bag of marbles. Select true or false for each statement. All right, so before we actually look at what they're asking us to solve, let's go ahead and just look at the general mathematical concepts here. So first of all, when you're dealing with probability, one thing you really want to know is how many do I have total? I have a total of 16 marbles. That represents the total number of outcomes. There's 16 different marbles that I can pick out at any given time. Now, out of those marbles, it says that 5 are blue and 9 are yellow, and that 2 are red. And of course, 5 plus 9 is 14, 14 plus 2 is 16, giving our total of 16. So let's talk about probability. All right, so probability did I spell that right? Probability equals the number of winning outcomes over the number of total outcomes. And by winning outcomes, we mean what it is that you are trying to select or what it is they are asking you to select. So if we take a look at first at blue, and we use the symbol P for probability, if I want to know what is the probability of choosing a blue marble, I'm going to say, okay, winning outcomes, how many blues are there? There are 5. And how many total marbles are there? We said that was 16. So the probability of choosing a blue marble is 5 out of 16. All right, the probability of choosing a yellow marker, did I say marker? I meant marble, is 9. There are 9 yellow marbles out of 16. So if I look at these two, it makes sense that I have a greater chance of choosing yellow than blue because there are 4 more of them. And finally, we have red. The probability of choosing a red marble is only 2 out of 16 or 1 out of 8. So if we're looking at these, we have the greatest chance of choosing a yellow, followed by a blue, and the least chance is for choosing a red. All right, so let's take a look now at what they are asking us. Again, we're determining whether each statement is true or each statement is false. It is impossible that a green marble will be selected. Well, we have blue, we have yellow, we have red. There are no greens. So I'm going to say true at that. It is unlikely that a yellow marble will be selected. Well, I don't really like this question because I would ask, well, what does unlikely mean? That's not really a mathematical term. But if we take a look at this, I think we can decide pretty clearly that it's not unlikely. In fact, it's 9 out of 16 is greater than half. Would you guys agree? 8 out of 16 would be 1/2, which would be what, 50%? 9 out of 16 is greater than 8 out of 16, which means we have yellow is a greater than 50% chance. So I think we can say pretty confidently that that is a false statement because we have more than a 50% chance of getting a yellow. But again, unlikely is not a super clear mathematical term. It is certain that a blue marble will be selected. Well, again, certain. What does certain mean? Certain means it's certain to happen. It must happen. Well, there's only 5 marbles that are blue. It is certainly not certain. All right. In fact, 5 out of 15 would be 1/3. If we had 5 out of 15, that would be 1/3 or about 33%. Correct? 5 out of 16 is less than 5 out of, is less than 5 out of 15, which means that it is less than 33. By the way, it's not exactly 33%, it's 33 and 1/3%. So it is anything but certain. In fact, we have about a 2-to-1 chance that we won't get blue. So I'm going to say false for that one as well. It is unlikely that a red marble will be selected. Well, there we go again with that term, unlikely. Well, let's take a look at it. We already said that it's 2 out of 16 or 1 out of 8. So we have a 1 out of 8 chance. Does that qualify as unlikely? All right, so if we're picking 16 marbles, there's only 2 of them that are going to be red. Or if we were picking 8 marbles, there would only be 1. So I would say yes, it is unlikely. But again, I'm not really crazy about this term unlikely. It was pretty clear here because we had greater than 50% chance, but I'm going to go with that. So there we go. So we're going to go true, false, false, true. All right, here we go. Next question, number 12. David goes into a candy store with $5. He buys 9 peppermints for 15 cents each and some sour candies. Each sour candy costs 25 cents. Enter the maximum number of sour candies that David can buy. All right, so let's take a look at this, reading carefully. David has a total of $5. If he has a total of $5, then that means he must spend less than or equal to $5. He's going to spend less than or equal to $5. Well, what is he spending it on? Well, he's spending it on candy. Surprise, surprise, he's in a candy store. The first thing they tell us is we have 9 peppermints for 15 cents each. So we're going to spend some money on peppermints, and we're going to spend some money on, I'm going to call them sours, and the money we spend has to be less than or equal to $5. So how much is he spending on peppermints? Well, he's buying 9 peppermints at 15 cents each, which means we are going to multiply 9 times 15. All right, so here we go. So I'm going to go 0.15 times 9. 9 times 5 is, oh my goodness, I just looked over here, and what did they let us use? A calculator. Now, you shouldn't have to use a calculator, but I just wanted to point out to you, when you are taking this test, when you see that calculator there, you can use it. So I probably would do this without a calculator, but since we are preparing for the actual test, let's go ahead and use that calculator. Whoops, there it goes. All right, so we are going to do 9 times 0.15. All right, and our answer, it says, hey, your answer show up on this side, $1.35. So 9 peppermints at 15 cents each is going to be $1.35. So if we go back here It is 135, and we got that answer from the calculator. Okay, so that means he spent $1.35 on peppermints plus however much he's going to spend on sours is going to be less than or equal to $5. So what we have right here is an inequality. Now, if I put equals instead of less than or equal to, it would be an equation. But because it says what is the maximum he can buy, that means he could buy that many or less. So if I want to know how much he can spend on sours, what do I need to do? I need to take away the amount that he has spent on peppermints. So I'm going to go back over here and I'm going to do $5 minus $1.35. And I know I have the calculator available, but I'm going to do this without a calculator. I'm going to need to borrow here. 10 minus 5 is 5. I'm going to have to borrow from this one as well. And so now I'm going to have 9 minus 3 is 6, and 4 minus 1 is 3. So that means he has $3.65 left for sour candies. All right, but what does it tell us? It tells us that a sour candy costs 25 cents. So if he has $3.65 to spend on sour candies, and each one is 25 cents, I need to take that number and I need to divide it by 25 cents. How many quarters are in $3.65? And again, I would probably do this with mental math, but I think it's good for you guys to get practice using a calculator because there will be some problems that are probably going to be a little more complicated. So I'm going to pull the calculator back up and I'm going to do $3.65. Oh, I should clear this out because it did not. I'm going to press clear all and start over. Here we go. $3.65, 65 cents, Mr. Reeves. And I'm going to divide that by 25 cents, 0.25, and I get 14.6. 14.6. So if we go back to where we were, when we divide this, we get 14.6 sour candies. Now I have a question for you. Is he going to buy 0.6 of a candy? And the answer is no. So, all right, can he buy 15? No, he can't buy 15 because if he bought 15, that would be too much money. All right, can he buy 14? Yes. So the most candies he can buy is 14. He can buy 14 or less. So since they asked us to say what the maximum was, we're going to go ahead and put in 14 candies and head off to the next question. So just a reminder, guys, keep a lookout for that calculator. When the calculator appears, you are able to use it if you want to. You certainly don't have to. You're welcome to figure them out by hand. Not a bad idea, though, to check your answer, even if you do work it out by hand on that calculator. And be careful when you're using it. As you saw, it's good to clear it out every time. I didn't do that at first. And if I wasn't careful, I might have gotten the wrong answer. All right, so 14 for number 12. On to number 13. Here we go. Sarah buys a sweater at a department store. The sweater costs $30. The store is having a 25% off sale on everything in the store. Enter the amount of money in dollars Sarah saves from the sale. Do not consider sales tax. All right, so let's read this question part carefully. It says, enter the amount of money in dollars Sarah saves. We want to know how much money she is saving, and we're not going to worry about sales tax. All right, so $30 is the total cost before the sale, right? So before the sale, she has $30 that she would be spending, but she is getting 25% off. And 25% can be written as 0.25 or 25 hundredths because percent is always over 100. So in this case, we had 25%, so that would be 25 over 100 or 0.25. So what we need to answer is, what is 25% of $30? And to do that, we're going to take that 25% like we already did, and we're going to write it as 0.25. And seeing that word of, that is our clue that we are going to multiply. So we're going to do 30 times 0.25. And again, we could do that certainly by hand this way. But again, I notice over here that I have the calculator available. So I'm going to go ahead and use the calculator, and I'm going to type in 30 times 0.25. And when I do 30 times 0.25, over here I see my answer is 7.5. Or in terms of money, that would be $7.50. $7.50. So that is how much she saved. $7.50 is 25% of 30. And they didn't ask us, but if they had asked us how much does she actually have to pay, then we could do $30, take away the $7.50, and we would get $22.50 is what she would pay, which is 75% of the original cost. But we were not asked that. We were only asked what she saves. So we're going to go ahead and put in 7.50. And by the way, I don't see a dollar symbol anywhere there. So I'm going to go ahead and use my keyboard and put the dollar symbol there. But it's not letting me put the dollar symbol there. So I guess I can't put the dollar symbol there. So 750, and I don't think it'll let us type the word in either. So if you were in my class doing this question, I would want you to put in units, but apparently it's not going to let us put in any units. I would love to see a dollar sign right there, or I would love to see the word dollars afterwards, but it's not going to let us do that. So we're just going to put 7.5, knowing it's $7.50, and we're going to move on to question number 14. All right, question 14. An electrician is hired to install outdoor lighting. The electrician claims that the relationship between the number of hours worked and the total work fee is proportional. We're going to come back to that. The fee for 5 hours of work is $225. Select all. Select all. Let's remember that. Select all combinations of values for the electrician's work hours and total work fee supports the claim. That supports the claim that the relationship is proportional. All right, well, I believe we did a previous problem about proportional relationships, but just to review again, in a proportional relationship, we have a value of k, which is called the constant of proportionality. And the constant of proportionality, k, is equal to y divided by x. Now, I don't see any x's or any y's or any k's anywhere in this problem, so we have to ask ourselves, what does y and what does x represent? Well, y represents an output and x represents an input. And so the question we have to ask ourselves is we have hours and we have cost, right? That represents cost. And the question I want to ask you is, does the number of hours he works depend on the cost, or does the cost depend on the number of hours of work? And if you think it through, it's going to be that the cost depends on the hours of work. So the output is going to be the cost, and the input is going to be the number of hours. So if we do the cost divided by the hours, that will give us K. So if we take a look at what they gave us right here, they've given us a cost of $225, and they've given us some hours that are 5. So I'm going to do 225 divided by 5. And yes, we have the calculator available, but I'm not going to use the calculator. So 5 goes into 200 and 5 goes into 22, 5 times 4 is 20. I'm going to subtract and I get 25 because I bring down the 5, and 5 goes into 25 5 times. So our constant of proportionality is 45. Well, what does that mean? That means that the electrician is charging what? $45 per hour. It just happens to be what we call the unit rate, because when we find the value of K, that tells us the unit rate. Okay, so if any of these are going to be correct, then the dollars divided by the hours must equal what we figured it out to be, which is what? 45. That's what we're looking for. The cost dividing by the hours is going to be 45. So, all right, so I am going to go ahead and use the calculator. So on the first one, by the way, you can move this calculator around. I'm going to do 270, and I'm going to divide it by 6. And when I do that, I get 45. What was the magic number we were looking for? 45. So I'm going to go ahead and put a yes on that one. All right, then I'm going to clear it out. Next, I'm going to do 315, and I'm going to divide by 6.5. And I get 48.46, da, 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 da. So that one is no. All right, going to clear that one out. Then I'm going to do 360, and I'm going to divide it by 8. And what do I get? 45. We have ourselves a winner. Then I'm going to clear that out. Then I'm going to do 8.75 and divide that by, whoa, no. That's the wrong order, Mr. Reeves. All right, let's do this in the right order. We're going to do the dollars divided by the number of hours, and that is not 45. And what do you want to bet that the last one is? I'm thinking it probably is going to be 427.50, and I'm going to divide that by 9.5, and surprise, surprise, we get 45. So nice and symmetrical. That was so nice of them to do that for us. All right, so there we go. Those were the choices that we wanted. There's the work that supported it. All right, and we've got our answers put in, and we are ready to move on to our last question for this video, question number 15. All right, here we go. Figure A is a scale image of figure B. The scale that maps figure A onto figure B is 1 to 7 1/4. Enter the value of X. All right, so what do we need to do? We need to talk about what it means for something to be a scale image of something else. All right, so if I were to ask you to compare these two, you would probably tell me, hey, they are both triangles, and that would be correct. All right, but there's more to being a scale image than just being a triangle. So I'm going to go ahead and make a triangle like this, and then I'm going to make a triangle like that. Are they both triangles? Absolutely. Are they scale images of each other? Absolutely not. If you compare these two and compare these two, and I ask you to say, okay, what do you notice about these two triangles versus these two triangles? Not only are these both triangles, but if you take a look, all right, if I were to shrink this one down, if I could pull it by the corner, it would look the same. There's no way to shrink this one down and turn it into this one, or make this one smaller and turn it into that. A scale image, it's the same shape but a different size. Or another way to talk about it is, this angle right here is going to be the same as that angle right there. And that angle right there is going to be the same angle as that. So all of the angles are the same, even though the lengths are different. These angles are not going to be the same. Also, the sides are going to be proportional. So if they are a scale image, the angles are the same and the sides are proportional. Do you remember in the previous problem? A proportional relationship, y divided by x was k. It was a constant. All right, so what is that proportion? Well, they actually tell us down here. 1 to 7 and 1/4. Well, I hope you guys all agree that this triangle is bigger. So what they're saying is, if something were 1 on this triangle, it would be 7 and 1/4. Or to get from this triangle to this triangle, I'm going to multiply by 7 and 1/4, or 7.25. In other words, all of the sides on this bigger triangle are 7.25 times as big as the ones on this triangle. Now, obviously, this side length is not 1. In fact, it looks a lot like it might be what? 3. So instead of multiplying 1 by 7.25 to get that, what do I need to do? I need to multiply 3 by 7.25. This triangle is 7.25 times as big as that one. All right, so since they're asking us to find the value of x, x is going to equal, again, 3 times 7.25. All right, and again, we could use a calculator if we wanted to, but come on, guys. 3 times 7 is 21. And 3/4 makes what? 75 cents, 21.75. But remember, I said you could check your work on a calculator. So let's go ahead and check our work on a calculator. We had 3 times 7.25. And when we do that, we get 21.75, just like we said we would. All right, so the answer that we are looking for is 21. Got to pull it down a little more so I can get that decimal point. 21.75. All right, and that takes us to question number 16, which we will pick up in the next video. Thanks for watching, guys. We'll see you next time.